Hello, this is Jack Jackson. In our last video, we talked about how to measure angles, and we introduced the idea of radian measure, which basically gives the amount of rotation a point traces through as a circular arc as it goes from a point 1 unit away from the vertex on the initial side as it rotates around through the rotational angle, landing on the terminal side. We're also going to introduce a more ancient system of measurement called degrees and degrees, minutes, and seconds, and learn to convert among these different measures. So, just very quickly review, we move out along initial side, which gives us a length of 1. We rotate that around, and we see how far that travels through the rotation. If the rotation is this way in the clockwise direction, it's a negative angle, and if it's rotating the other way, it's a positive angle, and that arc length, that signed arc length, is the measure of the angle in radians. But we have a more ancient system of measurement called degrees, and the basic conversion for degrees and degrees, minutes, and seconds is that a half circle rotation, which we know as pi radians, is also known as 180 degrees. In other words, a full circle rotation would be 2 pi radians, or 360 degrees. We can list angles measured in degrees and just give parts of a degree in decimal form. Those are called decimal degrees, or just degrees. But an even more ancient way is to divide a degree up into 60 parts, and each one of those is called a minute. So 60 minutes equals 1 degree, and 60 seconds then is 1 minute. This ought to be familiar to you from time also, because we do time the same way. 60 seconds of time is 1 minute of time, and 60 minutes of time is 1 hour. In angles, 60 seconds is 1 minute, and 60 minutes is 1 degree. We use a single prime here for a minute, a double prime for seconds, and then the little circle, raised circle, for degrees. So these are your basic conversion factors. Okay. So how can we do some conversions? So for example, suppose we start with degrees. Well, one of our basic conversion factors is that we can take these, since pi is equal to 180 degrees, the fraction pi over 180 degrees is actually equal to 1. Or 180 degrees over pi is also equal to 1. That's pi radians. But remember, radians aren't an actual unit, so we don't write any units on that. So, for example, if we have an angle of pi over 2, okay, let's think about where that would be. Well, a full circle would be 2 pi, a half circle would be pi, and so a quarter circle would be pi over 2. So that is a right angle then. It's called a right angle. So there's a measure of a right angle. What would that be in degrees? Well, we can take pi over 2 and just multiply it by a fraction equal to 1, but we want our answer in degrees. So we put our 180 degrees on the top of our fraction. That's equal to pi radians here. Notice that the pi's cancel, the 180, the 2 cancels, leaving us 90 degrees for a right angle. If we go the other direction, let's say we have 45 degrees. This time we need the degrees, so that's 45 degrees over 1 if you'd like. We want to multiply by a fraction that's equal to 1. This time we need the degrees in the denominator. So we put 180 degrees in the denominator and pi in the numerator. These cancel, and you can cancel out the 45 and the 180, and we get 4. 4 times 45 is 180. And so that answer, that 45 degrees, if it's exactly 45 degrees, it's exactly pi over 4 in radians. And if you want an exact answer, you're going to have to leave the pi in there. if we need an approximation for that, then we can take our 45, so there's our 45 divided by 180 is 0.25, or we can change that to a fraction, is 1/4, so it's pi times that, or pi over 4. So we multiply that by pi. This will be a decimal approximation, about 0.785398. Well, anyway, 0.785398. 634, as far as my calculator will go. This is an approximation. This is exact. This is approximate. Now, this is exact if this is exact. So if the original one is exactly 45 degrees, then the angle also is measured in pi over 4 exactly. Okay? Now, in this particular one here, we can do some conversions by working with these conversion factors. So here's an angle that's not exactly but approximately 45.12340 degrees. How do we convert that to degrees, minutes, and seconds, and radians? Okay, I've got the details worked out here. So first of all, let's look at the part at the bottom down here first. To change to radians, all you have to do is multiply by pi over 180 degrees. So 45.12340 times pi, and use the pi button on your calculator. Don't round it off to 3 or 3.14. Use the pi button so you get all the digits on your calculator to use. So that will not be our limiting factor. And then divide by 180 and enter, and we get 0.78755189997. Okay. Now the original one was 1, 2, 3, 4, 5, 6, 7 significant digits. So this should be 7 here. 1, 2, 3, 4, 5. There really should be 2 more digits. It should be 1, 9 after that. Okay, so that's converting to radians. Now what about degrees, minutes, and seconds? Okay, well, if it's 45 point something degrees, we know the 45 degrees is the whole number of degrees. So we've got the 45 degrees, and then we have the rest of it, the 0.12340 degrees. We can convert this part of the degrees, the fraction part, the decimal part there, by multiplying by a fraction equal to 1. We need the degrees to cancel out, so we need the degree symbol in the denominator. Now, so then we need 60 minutes is 1 degree. The degrees cancel, and we're left with minutes. So on our calculator, if we start with the 45.12340, first thing we have to do is subtract the 45 and get it out of the way. Now we take that and multiply by 60, and this will be how many minutes that we have for the decimal part. So we have 45 degrees and 7.404 minutes. Now, that means we have 7 whole minutes, and then the fraction of the minutes, then we can split off. So it's 45 degrees plus 7 minutes. Let's take away the 7 minutes, and we're left with 0.404 minutes. We take that 0.04 minutes, 404 minutes, multiply by 60 minutes over 1, 60 seconds over 1 degree. Let me fix this as a typo. That should say seconds. Okay, that's better. 60 seconds is 1 minute. Minutes cancel, I'm left with seconds. So in our calculator, we take the 0.404 part, multiply it by 60, and that gives us the seconds, 24.24. Now, notice these are pluses. 45 plus degrees plus this much degrees. 45 degrees plus this many minutes. 45 degrees plus 7 minutes plus this minutes, and so forth. So it's 45 degrees plus 7 minutes plus 24.24 seconds. But we typically suppress the pluses when we write it out. So we just write it as 45 degrees, 7 minutes, 24.24 seconds. Now if you have this Geometry Sketchpad sketch, you can put in any angle that you want here. 21.256, hit enter, and it will redraw it, and it will also show you all the steps in the conversion. So you can use these to check some of your conversions, but you need to be sure you can do this with simply just your calculator and no help here. This will also give you an idea. You can play around with this sketch, both the radians and the degrees. You can play around with this to experiment with different angles to get a feel for visually what a certain size angle is. Like if I said 60 degrees, can you figure out about where this is going to be before I type it in, before I hit enter? Well, there it is. Or what about in radians? If we click over here in radians, what if I click a radian measure of 2.1? Where's that going to be? Did you expect something like that? Okay, and so we can again, what if we're going to convert that to degrees? Okay, we can take the radians to convert to degrees by multiplying by 180 degrees over pi radians. Again, there's the radians you really don't write, but if you did, they would cancel out. There's really no units there. So we ended up with degrees. Now this is approximately 2.100 radians, so now I have to do this with the calculator. Alright, 2.1 times 180. There we go. And divide by pi. Again, use the pi button on your calculator, and there we get 120.321137. This is really, well, if these zeros are significant, that's 5 significant digits, and so this should be 5. It should really be 120.32 and stop there. If this was just 2.1 rounded to the nearest tenth of a radian, then we would round this to 120 rounded to the nearest 10. Now, if we're going to go from radian measure to degrees, minutes, and seconds, you go by way of degrees first. So, to go decimal degrees first, and then this is just like the problem we worked a while ago. You split off the 120, and you're left with the 0.32114 degrees. Multiply that by 60, and that gives you how many minutes that is. 19.26 whatever minutes. Take off the 19 minutes, so now we know it's 120 degrees 19 minutes. Take the 0.268, etc., multiply by 60, and then this gives you what's left, about 16 seconds. So again, you can experiment with this to get different angles. What if we start with degrees, minutes, and seconds? Well, this one here allows us to do that. So we can enter in a certain amount here, 18 degrees, 12 minutes, and 30 seconds. And there is the angle. How can we do our conversion here? Well, here are the details on the conversion. Okay, so we have, it's 18 degrees plus 12 minutes plus 30 seconds. The 12 minutes we can multiply by 1 degree over 60 minutes. The minutes will cancel, and this is degrees. We can multiply the 30 seconds times 1 minute over 60 seconds. The seconds will cancel, will be in minutes. Then we multiply by 1 degree over 60 minutes to get the minutes to cancel. And actually, this can all be typed in one line on the calculator. 18 plus 12 divided by 60 plus 30 divided by 60 divided by 60. Enter. And that gives you your 18.2083 repeated. Again, we would round off. Now this one, we can see that about 5 decimal places here is about the same as to the nearest second there. Now, if you want to go all the way to radians, we would take the decimal degree version, multiply by pi over 180 degrees, and we get this. It's very important when you're doing this that you do not round off in the middle of a calculation. So even if this was supposed to be a final answer of 18.2 degrees, for example, you would not use the 18.2, you'd use all the digits in this calculation and then round off your final answer here. That can definitely make a difference to you in some problems. So, we saw that if we start with radians, we can go from there to decimal degrees, and to do that we multiply by 180 degrees over pi, which is just multiplying by 1. If we had decimal degrees, we can go to radians, and there you multiply by the reciprocal, pi over 180 degrees. We can go from decimal degrees to degrees, minutes, seconds, and we can also go back this way. So if you want to go from radians to degrees, minutes, seconds, you go by way of decimal degrees. Radians, then decimal degrees, then degrees, minutes, seconds. Okay, so that gives you an idea of how you can do the different types of conversions, and I think we've done at least one of each kind, so that can help you practice there.